All right, so we've had a request for day 4, number 14, and this is a this is a calculator question, but it's to also prove it. And you know that on your quiz, it's going to be non-calculator. So, okay, first thing is if they provide you with the graph, okay, this is the graph, you look at it and be like, oh wow, it's a vertical tangent, cool story. Okay, so that's what you would do if it's a graph. You would say not differentiable at x equals 0 because of a vertical tangent. Okay. But in terms of the proving it, you are going to have to use your left and right hand derivatives. Okay. So we're going to start with our left hand derivative. And you can use difference quotient, but I actually feel like the alternate definition of derivative is easier here. So that's the limit as x approaches, and this would be 0. And I know it's 0 because underneath here, this is just an x, and so the issue is going to occur at x equals 0. If it was x minus 2, then you know you would have an issue at x equals 2. All right, so moving on. So limit as x approaches 0, we're going to go from the left of f of x minus f of 0 all over x minus 0. And I'm going to go ahead and plug all this in. So f of x is 3 minus the cube root of x, minus f of 0 is 3 minus the cube root of 0, all over just x. Cube root of 0 is 0, and then this is going to be 3 minus 3, so all that's going to cancel, and really what you're just going to be left with is a negative cube root of x over x. Well, this is the same as x to the 1/3. All right, and you could say times the negative 1 here. So now what I'm going to do is just subtract my exponents. 3/3 minus 1/3 is 2/3, and this is going to be, did I say that right? 3/3 minus 1/3 is 2/3, and that's going to be a 2/3 on the bottom. So now we did one similar to this on your notes. Yeah, it's like this one. Except for now we have a 2/3 in the bottom, x to the 2/3. So this was number 2 on day 3. So plugging in a number to the left of 0, that's like a negative. So you have a negative, you're squaring it, which is positive, you're taking the cube root of it. Okay, so the bottom's going to be positive, but the top is still a negative 1. So this is going to be a negative infinity. All right, and now we're going to do the right-hand derivative. And we're just going to jump to this step because all the algebra is going to be the same. This is just the limit as x approaches 0 from the right, and you have a negative 1 over x to the 2/3. And you're going to see when you plug in a positive number for x, it doesn't change anything because you still have a negative 1 on top, and you'd still have a positive on the bottom. So this gives you a negative infinity again. And because these are both a negative infinity, this is, we're going to say not differentiable at x equals 0, and it's because we have a vertical tangent. And that's because the left-hand derivative and the right-hand derivative are both negative infinity. Okay, so hopefully that answers that for you. If it doesn't, let me know.